Hello everyone, this is Dr. Young, and in this short video, we're going to talk about how to name some simple acids. I'll give you a couple of examples to name on your own, but we're talking about not really big, complicated things. There's a lot of great nomenclature around acids, but we're just talking about simple things that you might see in a chemistry lab, hydrochloric acid, sulfuric acid, those sorts of things. Where do those names come from? So first, right, acids just in general, and again, we'll talk more about this later, acids just proton donors, and by protons, we literally mean like that thing in the nucleus. So if you look at an H plus atom, it's just a proton. H plus is just a proton. It lost an electron, so literally just a positive charge, just one particle. Now these are proton donors. The way that we identify if something's going to be a proton donor, again for us, for right now, is that acids tend to start with a hydrogen. So when you see a formula, the formula is going to tend to start with hydrogen. So that means if I look at this first thing over here, right, I've got CH4. Yeah, that has a hydrogen in it, but this formula doesn't start with an H, it starts with a C. So I don't think that that is an acid, and I'm not going to name it as an acid. But if I look at the second thing, HCl, yes, that has an H also, and it does start with a hydrogen. And so I think that this is an acid, whether or not you happen to know that hydrochloric acid is in fact an acid. But if it starts with an H, it's probably an acid. So same thing over here. I have H2SO4. That starts with an H, so I think it's an acid. Here I have C2H6O for my next one. But again, yes, it has an H, but it doesn't start with an H. So I don't think that's an acid. And then lastly, I have H2CrO4. Again, I may or may not know what that is, but I see it starts with an H, so I'm going to circle it, and I think it's an acid. And so again, most acids, the way that you're going to see them at this point, start with hydrogen. And what we're going to see here is that when you have an acid and you identify like, oh, look, I have an acid, I am going to have to use two sort of different strategies to name these acids, depending on whether or not they have monoatomic anions in them. Remember that monoatomic just means one thing. So a good example of that would be the HCl from up above, right? Because this has an H plus made up of and a Cl minus, and the Cl minus, right? The anion, the Cl minus is just one atom. So that'd be a monoatomic anion. That'd be an acid with a monoatomic anion. If I looked at something like H2SO4, the second one that I circled up above, H2SO4, I know that that's made up of H pluses, but it's also made up of the sulfates. And the sulfate, right, is a polyatomic ion. And so we're going to have slightly different ways that we name these based on whether or not your acid has a monoatomic anion in it or a polyatomic anion in it. That's what we're going to talk about in this video. So, naming acids with monoatomic anions. The base is going to be, it's a hydro something-ic acid. And what we're going to put in here is this is where that anion name is going to go. The anion name where what you do is you change the "-ide". You just drop the "-ide" and put it in. So let me write that. Let me write that slightly differently here. So it's going to be the anion name, but you're going to drop the "-ide" ending. And I'll show you what I mean here in a second. All right, so like for example, HF. I know that HF is going to be hydro something ic acid. Now, if I was to normally look at this, right, I'd say like, oh, well, this is hydrogen fluoride. Right, if I was to name this as just a simple, right, whatever compound, hydrogen fluoride. But again, because I see it starts with an H, I know that this is going to be an acid, so I have to use this acid nomenclature. So hydrogen fluoride is really not the name. So what do I need to do? Like we said up here, I need to take that anion name and drop the "-ide, right? So I'm going to drop the "-ide from my anion name. Since the anion name was fluoride, that means I'm just going to take the fluor, and I'm going to leave the "-ide. I'm not going to take the "-ide. I'm just going to put fluor in there. So hydrofluoric acid. This would be hydrofluoric acid, right? Again, I just took that fluor and I popped it in there, hydrofluoric acid. Just like we would do hydrochloric acid, which we'll do in a sec. Same thing when I do this one right next to it. This would be hydrogen iodide. Again, starts with an H, so I know that I need to name it as an acid. So I'm going to call this hydro, and then I look for the anion name, which is iodide, but I get rid of the ide, so iode. So hydro, iodic acid. So this is hydroiodic acid. Hydroiodic acid is what HI is. And then lastly, for HCl, right, this is hydrogen chloride, or we would name it, we'd be tempted to name it hydrogen chloride. Again, these are not the real names. It's not hydrogen iodide, it's not hydrogen chloride. Because they start with H's, we're going to name them as acids, which means I take the chloride, I'm not going to use the iode, I'm just use the chlor. So I'm going to write hydrochloric acid. Right, hydrochloric acid, which is probably the one that you're most likely to have heard of before, right? It's your stomach acid. Hydrochloric acid is a real common acid, muriatic acid. So that's how you would name acids that just have simple anions, like hydrofluoric acid, hydroiodic acid, hydrochloric acid. Now, what if you don't have a simple anion and you have a polyatomic anion, a complex anion? Now, for these, all you're going to do is you're going to change the ate ending to ic and then say acid, or you're going to change the ite ending to us acid. So you're going to change the name of that polyatomic ion to either ic or us, depending on if it was ate or ite. So let's take a look at these three. I'm actually going to start with the one on the right here. So here I have hydrogen perchlorate. Let me write that down. Hydrogen perchlorate, which again starts with an H, so I know it's an acid. And like I just said, we're going to take that ate ending and turn it into ic. So this is perchloric acid, right? I got rid of the ate, I turned it into ic, said acid. And notice that this doesn't start with hydro, like hydrofluoric acid or hydrochloric acid. There's no hydroperchloric acid, it's just perchloric acid. All right, so I took that name, put it over here, said acid. Same thing if I do the hydrogen hypochlorite. So this would be, I'm just not going to say the hydrogen mark, I'll just write hypochlorite. Right, that's what OCl is, hypochlorite. Same thing, this ends in ite, so now I'm going to do the us, which means this is hypochlorous acid. So it'd be a hypochlorous acid, right? Because I'm taking the hypochlor and I'm making it hypochlorous acid. Again, it's not hydrohypochlorous, it's just hypochlorous acid. Now, hydrogen sulfate, right? Again, I'll just write the sulfate so that we can look at it. Hydrogen sulfate is a weird one. I don't know why this is weird, but sulfate, I mean, you'd think we would do the exact same thing where we take the ate and make it ic, but we actually keep the word sulfur and it becomes sulfuric. Sulfuric acid. There is no such thing as sulfic acid, which was what you might think it's supposed to be, but it's just not. It's probably just some sort of common name derivative type thing, but it is sulfuric acid. And again, that might be one that you've heard of before, like, battery acid or something like that. So, but in general, right, it still has an ic ending because its anion ends in ate. It's just that we have some extra letters in there for some reason. I'm not sure why. So here's a bunch of other ones. I recommend that you pause and take a crack at these, see what you can do, and then we'll come back and I will name them here for you, and so you can double check your work. So why don't you pause the video right now, see what you can do, get out your list of anion names. We've got a lot of polyatomic anions in here. So I'll stop talking for a minute. Okay, folks, so hopefully you had a chance to take a crack at these. I'm just going to name them real quick for you. Since this was hydrogen acetate, this is now acetic acid. Here we had hydrogen phosphate. And so now this is phosphoric acid. Again, notice that the things that ended in ate now end in ic, and then we say the word acid. Here's HBr, right? This is your bromide. So now we have hydrobromic acid. Because it's a simple anion, now we do use hydro in front. We change the I to ic, call it acid. Now here we have hydrogen bromate. So now this is bromic acid. Ate turns into ic. And we have nitrate as the polyatomic anion. So now it's nitric acid. Nitric acid. And now this is nitrite, right? I wanted to put these side by side, nitrate, nitrite. So now this is nitrous acid. So we have nitrous acid, right? Nitric acid, nitrous acid, the difference of one oxygen, right? With these oxo acids. Anyways, that's how you name acids. Some of them are a little weird, like sulfuric acid is a little bizarre, but the rest of them have fairly steady rules for how to name them. Again, the key to this is practice a whole bunch so you see lots of examples and are very comfortable with this. Keep up your studying and good luck.